Good morning, students. Today we are going to learn about how to write the VHDL code for D latch and D flip flop. Okay. Generally, flip flop is used to store a single bit. Okay. This is the VHDL code for D latch. Okay. In each VHDL program we have library part, entity part and architecture part. Okay. This is the block diagram for D latch. Okay. D is the input, Q and Q bar are the outputs of D latch. Okay. Here we have enable input. Okay. E is the enable input. Okay. In this program, D latch is the entity name, behavioral is the architecture name. Okay. Generally, in the entity part, the first line is entity name is. Okay. Entity D latch is. Okay. Next, I am declaring the input output ports of D latch. Okay. In D flip flop, we have clock. In D latch, we use enable input. Okay, so E is the input single bit value, so E colon I am using mode in, then std logic means standard logic, semicolon. Next I am declaring the input D, so D colon mode in, then std logic means standard logic. You can use bit also. Okay, bit semicolon. Next I am declaring the output Q. Okay, Q colon mode out, then std logic. Okay, std logic means standard logic. Okay, instead of std logic you can use bit. Okay, next in the third line end entity name is D latch, so end D latch. Okay, now the entity part is over. Next, architecture part. In the architecture part, the first line is architecture name of entity name is. Okay, here D latch is entity name, behavioral is the architecture name. Okay, so architecture behavioral of D latch is. Next you have to use begin. Okay, next in this program I am using process statement. Okay, process, open the bracket, then E comma D. Okay, if any changes occurs in enable or D, then it will execute the following statements. Okay, next you have to use begin. Next I am using if statement. If enable is equal to 1, then Q is equal to D. Okay, so here if open the bracket, E is equal to 1, then Q is equal to D. So Q less than equal to D. Q bar always complement of Q. So Q bar less than equal to not D. Okay, next I am closing end if statement. So end if. Next I am closing process statement. So end process. Here I am closing architecture. So end behavior. Okay, this is the VHDL code for D latch. Okay. This is the VHDL code for D flip flop with the reset. Okay. Next we will see the VHDL code for D flip flop with the reset. Okay. Here we have D reset flop Q and Q bar. Q and Q bar are the outputs of D flip flop. D is the input. In flip flop we have clock input. Okay, to activate the flip flop. Okay, by using reset you can clear the D flip flop. Okay, so here we have library part, then entity part, then architecture part. Okay, D flip flop is the entity name, behavioral is the architecture name. So entity, in the entity part, first line is entity name is. So entity D flip flop is. Next I am declaring the input output ports. Okay, Support to open the bracket, D is the input, reset is the input, clock is also input. So D comma clock comma reset colon in STD logic semicolon. Next I am declaring the output Q and Q bar. So Q comma Q bar both are outputs. So colon out STD logic. Here also you can use bit instead of STD logic. STD logic means standard logic. Okay. In the entity part, third line is end entity name. In this program, D flip flop is the entity name. So end D flip flop semicolon. Okay. Next architecture part. In the architecture part, first line will be architecture name of entity name is. Okay. In this program, D flip flop is the entity name, behavior is the architecture name. So architecture behavior of D flip flop is. Next you have to use begin. In this program also I am using process statement. Okay. Process. The inputs are D clock reset. So I am using here D clock reset. Okay. If reset is equal to 1, then Q will be 0. If reset is equal to 0 and clock is equal to 1, then Q is equal to D. Okay, this is the working of D flip flop. Okay, Q is equal to D. If D is 0, Q is 0. If D is 1, Q is 1. Okay. By using reset, you can clear the D flip flop, any flip flop. Okay. So if reset is equal to 1, then Q will be 0. If reset is equal to 0, then it will check the clock, if it is high or not. If it is high, then D is assigned to Q. So Q less than equal to D. Q bar is the complement of Q. So Q dash less than equal to not D. Okay. Here I am closing the if statement. Okay. Next I am closing the if statement of reset. Okay. Next I am closing the process statement. In the last line I am closing the architecture. So end behavior. Behavior is the architecture name. Okay. Next you will see the VHDL code for D flip flop without reset. Okay. Just you have to check the clock. If it is high, then Q is equal to D. Okay. So here also we have library part, entity part and architecture part. Okay. The same logic, but here we are not using reset. Okay. Just you need to check clock. Clock is used to activate the flip flop. Okay. Here also I am using the D flip flop as the entity name. Okay. In this program, D flip flop is the entity name. Behavior is the architecture name. Okay. So entity D flip flop is. Next I am declaring the input output ports. Here D and clock are inputs, Q and Q bar are outputs. Okay. So port to open the bracket D comma clock colon mode in, then STD logic. STD logic means standard logic semicolon. Next I am declaring the output ports Q and Q bar. So Q comma Q bar colon out. Next STD logics. STD logic means standard logic. You can use bit instead of STD logic. Okay. In the third line, you have to write end entity name. Entity name is D flip flop. So end D flip flop. So now the entity part is over. Okay. Next architecture part. Okay. In the architecture part, we know that the first line is architecture name of entity name is. Okay. In this program, entity name is D flip flop, architecture name is behavioral. So architecture behavioral of D flip flop is. Next you have to use begin. Okay. In this program also I am using the process statement. Okay. So process, open the bracket, the inputs are D clock. So D comma clock. Next you have to use begin. Just I am assigning 0 to the output Q. Okay. In the beginning, the value of Q is 0. Okay. Now I am checking clock. Okay, if it is high, then if it moves from 0 to 1, then D is assigned to Q. Q is equal to D. Q bar is the complement of Q. So Q bar less than equal to not D. Q less than equal to D. Okay. Now I am closing the if statement. Next I am closing the process statement. End process. In the last line I am closing architecture. Okay. So end behavioral. Behavioral is the architecture. Okay. Okay. Thank you.